Saxkn Advanced Mathematics, Lesson 8. We're warming up. We're getting close to talking about proofs. Don't let proofs freak you out. John's very gentle in the way he introduces us to them. Today we're going to talk about something close to proofs, and I'm going to explain the difference. In geometry, there's the word called congruency. It basically means equal. In geometry, when two shapes are equal, we don't say they're equal, we say they're congruent, okay? It means they have the same angles and the same length sides, okay? Things match exactly. But in geometry, as you know, we also have a concept that's called similarity. We say that shapes are similar sometimes, and that's a little bit different than equal. I often think of it as click and drag, right? Because you know how you can do that on a computer, you can size things up or down. You can do it on a phone too, with the right app. You are not changing. Let me just say it this way. We keep the same angles when we have similar shape, but they are different sides. And another way that we can describe that is to say that they are proportional. They're not equal, but they're proportional. So what's cool is that when we have similar triangles, we can create proportions, right? That's what we're gonna work on today. We've dabbled in that already. What we're doing today isn't completely new, but it's just the problems formatted a little differently. When we talk about proofs, which is lesson 9, I believe, it's coming up soon, we will be talking about triangles that are exactly the same. Today's lesson is focused on these kinds of shapes where they're not exactly the same, but they're proportional. So let's dive in and look at the first example. It says in a triangle, and it gives us a picture, one segment is the altitude to the hypotenuse, okay, and then it tells us to show a certain proportion. So let me just start showing you so you don't wonder what in the world I'm talking about. We have this picture. You and I have seen this before. There's a right angle marker here. There's a right angle marker here. A, B, C, D. All right, we have looked at this before, and we know that this is actually 3 triangles in one, right? There's the big triangle on the outside. There's a medium triangle here, and then there's a little one like this, all right? So we know that we're gonna be able to break this down into 3 different triangles that are similar. We've talked about that before, I'll remind you. But this is what John wants us to show. AD over AB equals AB over AC. Now I look at that and I just think, John, I don't even know what you're talking about. So let's figure that out. AD is this length. He wants us to show that AD is proportional to AB. Let's draw the triangles first. That will make it easier to see. Okay, let's do baby bear, mama bear, and daddy bear. Okay, we know they're all proportional. We just have to figure it out. They look like they're tipping over, but it's okay. Okay, A, D, and B. That is our baby bear, right? Medium guy, let's see, C is at the top, B is at the short end, D is at the right angle, right? We take it and go like that. And then this big one, the short leg is A, B is at the corner, C is at the top. Honestly, you guys, sometimes I think that's the hardest part of the whole rigmarole, is trying to get the 3 triangles stripped away and get the letters on it properly so that you can see what you've got here. If that messes you up at all, let me know because that is confusing. Okay, now let's try this. AD to AB, that's over here. And AB, no, AD is to AB as AB is to AC. Okay, so these are the two pink lines. And these are the two orange line. And what we're saying is that the short legs are proportional to the hypotenuses, the hypotenuse, right? We're supposed to try to prove that. Now we know that similar triangles have similar sides, so we can write a proportion that says short leg over hypotenuse equals short leg over hypotenuse equals short leg over hypotenuse. And that's true because similar triangles are proportional. How do we know these are similar triangles? Well, because I told you, right? That's one reason. But another reason we know that is because we can show that they all have 2 out of 3 triangles in common. This angle here, this is the same here as it is here, right? Angle A shows up in the large triangle as well as the baby triangle. So we can mark those two the same. We also know that this is a right angle. That's a right angle. That's a right angle. So they all have that in common. Now what about the medium, the mama, and the papa bear? They have this angle C in common. We'll put 2 ticks on that one. So now we can see that A and the little guy and the big guy, they have 2 in common, so they must match. The big guy and the medium guy have 2 in common, so they must match. And because these two both relate to the big one, we know that this third angle must also be the same, all right? Because they've got 2 out of 3. So we know that these guys are all proportional. And so this we know is proportional because similar triangles are proportional. And then we see that the two fractions or proportions that we're interested in, AD over AB equals AB over AC, that is what we were trying to show, right? So this is just 2 of the proportions that we had up above. If you're looking at this and going, how is this even a problem? We're just looking at this triangle and sharing what we already know. It isn't. You're exactly right. We're not doing anything groundbreaking here. We're just showing that we can take a figure and we can identify certain sides and we can draw conclusions about them. That's all a proof is. So we're getting ready to do that. Today we're working with proportions and similar shapes instead of what we'll be doing for proofs. All right, let's do another one. Here's another familiar shape. This is example 8.2. And it involves transversals. These little lines, as you'll recall, the little arrowheads, mean that the lines are parallel, which is important. And then we have two transversals cutting through, right? And we've got information about them. And what we remember is that these two segments will be the same proportion as these two segments. Okay, so we can use this to write a proportion. We're asked to find x. That's our instruction in this. Okay, so we can just use this exactly the way it's organized. We can write x plus 1 over 13 equals x plus 4 over 19. Okay, we know that transversals and parallel lines create segments that are proportional. And so that's how we're reflecting that right here. We cross multiply and we get 19 times the quantity x plus 1 equals 13 times x plus 4. We're just doing algebra now. 19x plus 19 equals 13x plus what? 52, right? Okay. Swim some fish. I decided to bring the 13 this way because 19 minus 13 will give me a positive number. Those all cancel. Once I decide to swim the x fish this way, obviously I'm going to take the plane that way. 6x equals 33. Divided by 6, and I can see that that will reduce because 3 goes into both of them. And I get x equals 11 over 2. Not the most satisfying answer I've ever gotten, but it's correct. So we used our knowledge about proportional segments in transversals to solve a little algebra problem. Okay, moving on to a different shape. And let me introduce the shape to you because we haven't seen this one. I don't know if we've ever seen it, but if we have, it's been a while. It's another shape that creates proportional measures. And it looks like this. We take a triangle and we're going to create a line down the middle that divides the angle here into equal angles, but also divides, no, that's what it does. So we're dividing it into equal angles. Pretend it's perfect. It's probably not. But these angles are now the same. And we're going to talk about the sides, so let's put letters on them. And there's two ways that we can create proportions here. We can say A is to B as C is to D, right? So we can go across like this. Or we can also say A is to C as B is to D. Both of those things are true. There's two ways we can state these proportions, and that's true in a lot of proportions, but we're just going over it here as well. All right? So there's two different ways to set it up. I personally prefer this one because I like to take the numbers and put them right into the proportion when we have numbers, right? I like to create my proportions by just taking it. This one you kind of go sideways and it goes from sideways to down. Sideways to down. That seems just unnecessarily cluttery in my brain, but it works as well. Okay, so now let's try an example. Now that we understand how these triangles are similar. 8.3, we're almost done by the way. We have one more example after this one, but they don't take long. Okay, so now we have another triangle that looks a lot like this. it's got a bisector, and we know that it's got a bisector because we see these markings. This is what tells us we have a similar side situation going on. Without that marking, we are sunk. All right. We've got some letters, and we've got some numbers. Now, let me read to you what it says. In triangle ABC, okay, yeah, that's this. Segment BD, oh, I forgot the D. Segment BD is the angle bisector of angle B. Okay, well, we knew that because those marks were on there. But they're just telling us, yo, that's a bisector, so guess what? The proportions are gonna work. So that's good news. Even though when I read it, it just kind of makes my head go in circles and annoys me. I'm happy to hear it because that means, okay, now I know how to do this problem. Find X. X is right here. All right, so the X is this side. So I know that these sides are all going to be proportional. I know I can set it up two ways. I know that I can do it my favorite way, which is 10 over X equals 15 over 12, right? I could also write 10 over 15 equals X over 12. If your brain feels better doing that, do it. My brain feels better doing this, so that's what I do. Now I cross multiply. 120 equals 15X. Divide that little doggy by 5. Let's see. 2 15s make a 30, and there are 4 30s in there, so that means it must divide down to 8. Did that make sense? 2 15s make a 30. 4 30s are in that. So 2 times 4 is how my brain sees that. That's the right answer. And one more. Example 8.4. This one kind of makes me laugh. Here's the picture. So it's a triangle, but look what John did. He put the bisector down here. He's got those marks on it, but he put it down here instead of up at the top. So it's like it tipped over, right? That's crazy. But I'm just gonna leave it. I'm not even gonna redraw it. Whatever, I don't care. This is D, 14 and 6. So we're gonna use this same idea that the angle bisectors create proportional sides. But I just have to be careful about how I set up my proportion because everything's tipped sideways. So I kind of turn my head around and reorient it so this is at the top, and then I use the same pattern of grabbing the number. So I'm gonna go 20 over 14 equals X over 6. And that's correct. All right, John did it differently, but I was just looking to make sure that my numbers equal his. All right, let's multiply. 120 equals 14X. Divide both sides by 14. We're not gonna get a pretty number, and I'm sad about that. But I will get X equals, we can divide these both by at least 2, right? 60 over 7. 7's prime. It doesn't go into 60. That's the end. Okay? Beautiful. That's lesson 8. Do the odd problems in the problem set. I'm just looking to see if there's any construction in here. I think, yeah, there's one odd numbered construction paper. Wait, I said the wrong thing. There's one construction problem in the odds. There's another one, the number 24, that has you drawing on a separate piece of paper. It's weird. And then you can skip the concept review problem at the end, number 29. So That is fabulous. Remember that what I want to reinforce to you is that today we were talking about shapes that are similar and they're proportional. They have the same angles but different sides. Next time we're going to talk about shapes that are congruent, which means that they're exactly the same. Same angles, same sides. We'll cover that next time. Thank you. Goodbye.